Today we're going to work on balancing some chemical equations. When we balance our chemical equations, we want to make sure that we're following something called the law of conservation of matter. Law of conservation of matter says that if we have 3 carbons as a reactant, we also have to have 3 carbons as a product in our chemical reactions because nothing is ever created or destroyed throughout the process of that reaction. So right now we're breaking that law. We need to make sure that we fix that. So in order to fix that problem, what we're going to do is we add coefficients in front of each of the compounds in order to change the number of each of the elements that are there. So I have several examples that we're going to do today, and I have some more rules that we're going to talk about as well. I'm just going to go through them one at a time, and I'm going to show you the general process on how to balance a chemical reaction. So the first reaction that we're going to balance, we have hydrogen. It's reacting with nitrogen, and we're making ammonia, which is also called nitrogen trihydride. So with this chemical reaction, the first thing that you want to do anytime you balance something is make something called an inventory. For your inventory, what you're going to do is you're going to write down how many of each of the different elements you have present. On my reactant side, I have 2 hydrogens and I have 2 nitrogens. On my product side, I only have 1 nitrogen because there's no number written after it, and I have 3 hydrogens. I need to make sure that all of these numbers are the same on each side of the reaction. In order to do that, I add my coefficients. So on this one, I'm just going to use the first one that I see. I have 2 nitrogens as a reactant. I need 2 nitrogens as a product. So I'm going to think about it in terms of what times 1 will give me the 2 nitrogens that I need, which this one's pretty straightforward. If we put a 2 in front of my NH3, that gives me now 2 nitrogens, but then that changes my hydrogens to 6 because these are stuck together. By adding that 2 out front, we had just 1 of them. Now we have 2 of each of those compounds, so I have 1, 2, 3, 4, 5, 6 hydrogens. Now I need to fix my hydrogens. I'm going to add a coefficient in front of my hydrogen over here to get me to 6. So I'm going to think about it in terms of what times 2 will give me the 6 that I need, which is 3. That changes my hydrogens to 6. There's no coefficient in front of my nitrogen here. That if there's no coefficient there, it's assumed that it's a 1. But chemists don't usually write the number 1. We don't a lot. So that 1 right there is usually just a ghost. You don't really need to write it, but it is actually there. Now the next rule, I guess you could call it, is we want to keep polyatomic ions together if they appear on both sides of our chemical reaction. So in our next example, I have silver 1 nitrate reacting with magnesium chloride. We're making silver 1 chloride and magnesium nitrate. Now with this one, I have a nitrate, NO3, right here. I also have a nitrate right here. So in order to balance this one out, in my inventory, I'm actually going to keep nitrate together as NO3. And I have magnesium and I have a chlorine. I have 1 silver, I have 1 nitrate, because this is not in parentheses, there's only 1 of them. 1 magnesium and 2 chlorine. Now on this side I have 1 silver, 1 chlorine, 1 magnesium, and 2 nitrate. I need to make sure that all of those numbers are the same down each side of the reaction. So I'm going to start with the first one that's just unbalanced, which is nitrate. With my nitrate here, on this side I have 2 nitrates. I need 2 nitrates over here. So 2 times 1 is going to give me my 2 nitrates that I need. But then that also changes my silver to 2, because these are stuck together. So now to fix my silver, I have 2 on this side. I need 2 on this side. 2 times 1 is going to give me the 2 that I need, but then that also changes my chlorines to 2. So with this one, I have a 2, a 1, which we don't need to write, a 2 and a 1 to make a balanced chemical reaction. Now the next rule that I have, oh wait, I'm sorry, this one goes with that same rule. So we'll do this one first. With this one, I have potassium chlorate. That one is decomposing. We're going to make some potassium chloride and oxygen. Now with this one, I have chlorate, ClO3, that's a polyatomic ion. But I do not have chlorate on this side of the reaction. So if I don't have chloride on this side of the reaction, I actually have to break it up into potassium, chlorine, and oxygen on each side. I just changed colors so that way we kind of keep that purple separate. So on this side I have 1 potassium, 1 chlorine, and 3 oxygen. On my product side I have 1 potassium, 1 chlorine, and 2 oxygen. So what we're going to do here is we need to make sure that our oxygens are fixed. On this side I have 3, this one I have 2. I have to end up with the same number, so we're going to go back to those math skills again. And with those math skills, I know that they both have to go up to the same number, which the same factors of these would be 6. So I need to get this side to 6 and this side to 6. If I fix this one first, I'm going to think about it in terms of what times 2 will give me 6, which is 3. That changes my oxygens to 6. Now to get this side to 6, what times 3 will give me 6 is 2. So I'm going to put a 6 right there, but then that changes my potassiums to 2 and my chlorines to 2. So now I need to fix my potassium over here. To fix my potassiums over here, if I put a 2 out front there, that's going to give me 2 potassium and 2 chlorine. That actually fixes everything, so my coefficients are a 2, and a 3 in front of my compounds. Now on this next example, my rule says to save oxygen, hydrogen, or split up elements for last. So with my next example, this is called a combustion reaction that we'll talk about in my next video. But with my combustion reaction, I have an oxygen here and I have an oxygen here. They're both products and they're split up. I'm going to balance out my oxygen totally last in hopes that everything kind of works out a little easier. So carbon will be first. I want to save hydrogen and oxygen for last. Oxygen is totally last because they're split up. So I'm going to do carbon, hydrogen, and then oxygen. Now with this one I have 3 carbon and 1 carbon, 8 hydrogen, and 2 hydrogen. My oxygen I have 2. Then over here I have 2 right here. I have 1 right here. 2 plus 1 gives me 3 total. I want to fix my carbon first. On this side I have 3. I need 3 over here. 3 times 1 is going to give me the 3 carbon that I need. But then that also changes my oxygens. 3 times 2 is 6. We've got to count this guy over here. That's 1 more. So that now gives me 7. Now I want to fix my hydrogen. To fix my hydrogen here, I have 8 on this side. I need 8 on this side. So what times 2 will give me 8 is 4. That changes my hydrogens to 8. But now my oxygen, I have 4 here, but then we can't forget about these 6 over here. So 6 plus 4 is going to give me now 10 oxygen. Now I need 10 oxygen over here. With my 10 oxygen over here, what times 2 will give me 10 is 5. That changes my oxygens to 10. Now everything's balanced. So my coefficients are a 1, which is not there, a 5, a 3, and a 4. Now where that doesn't work is if you have, well it would work I guess, but to make our lives a little easier, we have our hydrogen split up over here. Now this kind of follows into a couple different rules. We have keeping our polyatomic ions together and keeping split elements for last. Now if you have water is H2O, you can rearrange water and write it out as H and then OH, like hydrogen and hydroxide. If you do that, sometimes it actually kind of alleviates your issues and it makes your life a little easier to balance out our reactions. So if you see water in your reaction, you're going to look at the other side. When you look at the other side down here, we have a hydrogen and we have hydroxide. So what we're going to do on this one is we're actually going to write out our water as HOH instead of thinking about it in terms of H2O. When we do that in our inventory, now I have sodium, I have hydrogen, and I have hydroxide. That is going to save us from having your hydrogen split on this side. So when we balance out this reaction, I have 1 sodium, 1 hydrogen, 1 hydroxide. On this side, I have 1 sodium, 1 hydroxide, and 2 hydrogens. So I need to fix my hydrogens on my reactant side. So if I put a 2 out front there, that changes my hydrogens to 2, changes my hydroxides to 2. Now I need 2 hydroxides on this side. If I put a 2 out front there, 2 times my 1 hydroxide is 2. That changes my sodium to 2. Now I need to fix my sodiums over here. To fix my sodiums over here, I need 2, because I have 2 on my product side. If I put a 2 out front, now everything is all balanced out. It balances with a 2, a 2, a 2, and a ghost number 1 right there. So hopefully that clarifies anything that you need to do with balancing equations and just following all of these rules. Use coefficients to change how many of each of the elements. Keep your polyatomic ions together. Save your oxygen, hydrogen, or split up elements for last. And if you have water, you're going to look at the other side to see if you have hydrogen and hydroxide. If you do, split it up into HOH.